Hi, this is Fazana again. In this video, we'll cover some interesting exam questions. Please watch all my videos on volume and surface area, on cubes, cuboids, prisms, cones, spheres, and pyramids before watching this, so you're comfortable with the basic concepts and really comfortable using the formula. Okay? All right, let's move on to the questions. Okay, a large carton juice contains 4 liters of orange juice. Okay, 4 liters, looking at the centimeters here, 4 liters is 4,000 centimeter cubed. All right. Cylindrical glasses of height 10 centimeters and radius 3 are to be filled from the carton. Yeah? So we're going to fill glasses. Yeah? Okay, and I'm sure the question is how many glasses? How many glasses can be filled? You must show all your workings. Okay, so we need to find the volume of this and then say 4,000 divided by the volume of this to find how many glasses. Yeah, so let's prepare first. So can you see by preparing it, you're like always one step ahead. Yeah, so we're going to go 4,000 divided by the volume of the cylinder or the glass, yeah, and out will come your number of glasses. Okay, all right. So the volume of the cylinder, always write the formula first. So you've got V equals pi r squared h, and then stick in the numbers. Pi times 3 squared times 10, which will give you 282.74. Okay, and then if you stick it in there, and you get 14.15, and of course you've got to round it down because we can only fill 14 glasses. Okay, an easy one, yeah? When they're diagrams, I find it so much more enjoyable because it's like you can actually visualize it. Yeah, good. All right, moving on, feeling cleverer. A water container is in the shape of a cuboid. Its base is 20 by 20 and the depth is 15. Tony adds 1,000 centimeters of water to the container. So you can see the 1,000 centimeter cubed would be that bit there. Okay, so again, draw. Can you see? You're actually, it just gives you a sense of direction of what to do. All right, calculate the new depth of the water. Okay, so again, I prepare. I'm going to find that depth there, and then I'll add 15. So here, I'm preparing. I'm going new depth equals 15 plus. Now I just have to find that depth there. Okay, yeah, which is, oh, it's not D, but I'm going to call it D. Yeah, D1. All right, okay. So what is that depth? Okay, again, can you see when you're taking that being 1,000 centimeter cubed, what isn't going to change? That 20 will stay the same, and that 20 will stay the same. Yeah, it's only the depth that's changing. Okay, so all we do is D1 equals 1,000 divided by 20 times 20. Okay, because you know when you're doing the volume, you're doing length times width times height. Yeah, in this case depth. So that length and the width won't change at all. Yeah, so they will be the same. Okay, and we're given the volume here. So here you get 2.5 centimeters. So that would be that bit there. Okay, so then your new depth will be 15 plus the 2.5, which is 17.5 centimeters. Wasn't that easy? Yeah? And yet when you look at the diagrams, you think, oh God, how am I going to get there? Okay. Next. a hemispherical bowl of radius 6 centimeters, so I'm already writing half there. Yeah, so that when I write the formula, I remember the half. Has the same volume, so equals, as a cone of perpendicular height 27 centimeters. Calculate the base radius. Okay, so we're calculating that. Okay, anytime they say it's got the same volume or twice the volume, I always make sure I've got it in a horizontal layout, and I'll show you why. Yeah, it'll make it so much easier. So first I write the formula. So the formula for the volume of a hemisphere is 2/3, because it's half of the 4/3. Yeah, so half of 4 is 2. So 2/3 pi r cubed equals 1/3 pi r squared h. Okay, now we'll go write our numbers in. So we've got 2/3 pi times 6 cubed equals 1/3 pi r squared, and we don't have the radius, which is what we're finding, times 27. Okay, I always do my numbers first. So here I go 2/3 of 6 cubed, and my calculator gives me 144, and then I stick my pi in, and then 1/3 of 27 is easy, so you've got 9 pi r squared. Okay, we'll take away the pi because it's common on both sides, so now you know why it needs to be a horizontal format, so we can see the whole picture. So we'll take away the pi, so we've got 144 equals 9r squared, and then it's just flowing, divide by 9, which is 16, equals r squared, square root, and you get r equals 4. Okay, yeah, wasn't that easy? Okay, and you can see the layout is so brilliant. If you're doing anything wrong, it's just going to jump out at you. Yeah, all right, nice and simple. Always keep it really nice and simple with volume and surface area. Yeah. Okay, as with everything in life itself, keep it simple. Okay, the radius of the base of the cone is x, and its height is h. The radius of the sphere is 2x. The volume of the cone and the volume of the sphere are equal. Okay, so we've got an equal. We're going to do the horizontal layout. Yeah? And we have to express h in terms of x. So h in terms of x means we go h equals something x. All right? Okay, so let's do our formula first. So the volume of a cone is 1/3 pi r squared h equals 4/3 pi r cubed. Okay, all right, let's go stick in the numbers. 1/3 pi x squared h equals 4/3 pi. Now this is where they're testing you. Remember, it's going to be the whole of the 2x cubed. Okay, so this really works out to 8x cubed. Okay, and this is the key part of the question. All right, so again, let's work our numbers first. So we've got 1/3 pi x squared h equals, and now we're going 4/3 times 8, so on the side at the top, 4/3 times 8 would be 32 over 3. Okay, so we've got 32 over 3 pi x cubed. Now we look to see what they have in common, and you can see they've got pi and x squared in common. So we've got 1/3, that all disappears, and we've got h equals 32 over 3 pi x squared, so we're only left with 1x. Okay, and then when we multiply by 3, we get h equals 32x. Alright, again, nice and simple. Can you see just by doing that, you can play around with it. I always like to do my numbers first, just to then be able to see what they have in common in terms of pi and x's. Okay, yeah, good. We're getting clever, right? Okay, 3 spheres of radius 4 centimeters fit inside a tube. Calculate the percentage of the tube that's not filled. Not filled, remember. Okay, so when I'm preparing, I'm going to go not filled divided by volume of tube times 100. All right, yeah. Okay. Okay, so we can tell that bit there is the diameter. So if that's 4 centimeters, that whole thing is 8 centimeters. And the same here, that would be the diameter. That would be the diameter. That would be the diameter, and that would be the diameter. So that whole thing is 24 centimeters. Okay? Yeah? All right. Okay, so let's take the volume of the cylinder first. Volume of cylinder. Okay, I just put 3 here, so it's always at the behind at the top somewhere in my head. Okay, volume of the cylinder. Right, let's write the formula: pi r squared h. So that's pi times radius, which is 4. Yeah. Times 24, and you get 1206.4. Okay, all right. Now we're going to take the volume of, that 3 came back, 3 spheres. So it's 3 times 4/3 times pi r cubed. And this 3 is lovely, because we can see now we've just got 4 pi r cubed. Yeah, so we've got 4 times pi times the radius again is 4 cubed. And we get 804.2. We're looking for what's not filled, so we take that away from that, and we get 402.2. Okay? So your answer will be 402.2 divided by the volume of the tube, which is 1206.4 times 100 to convert it into a percentage, and you get 33.3%. Okay? Yeah? All right. Good question, yes? Okay, that's all for now. Please join me in part 2 for some more interesting questions. You'll soon be an expert on this topic. And remember, you're in control. Until next time, take care. Bye.